Section 1.2 is on dimensional analysis. So what that means is that we're going to be converting different measurements and different rates. So at the top here, I put a few of the conversion factors that we are going to use throughout the lesson, and that'll be on your quiz and test and that such thing. So I would suggest pausing the video and writing those down so you have them in your notes to be able to get out when you need them when you're doing your homework. Okay, so converting measurements. A dimensional analysis is a way of using units to help solve problems involving measurements. Conversion factors, this is important. Conversion factor is a ratio of two equivalent measurements. So I put an example of 12 inches over 1 foot. So you make a ratio or a fraction using units that are the same. So 12 inches is exactly the same as 1 foot. So this is considered a conversion factor as a fraction. So I'll show you how to use this here in example 1. The body of a large adult male contains about 12 pints of blood. Use dimensional analysis to convert this quantity to liters. There are about 2.1 pints in a liter. So that's important information. And to know that we have 12 pints is also important. So that's what we're starting with. We have 12 pints. And I'm just going to make it a fraction. I'm going to put 1 underneath of it. And we want to change this to liters. So that is why they gave us the conversion factor that there's 2.1 pints in a liter. So we're going to have to multiply this by a conversion factor. If we want units to cancel out, we want to change them, then we have to have 1 on the top and 1 on the bottom. So the pints is on the top here, and that's what I want to get rid of. I want to change to liters. So if pints is on the top of this fraction, I'm going to have to put pints on the bottom of this fraction. And then this is my conversion factor, so I'm going to go back up here to the information they gave me. 2.1 pints, so that number goes here, is the same thing as 1 liter. And we can cancel out our units, pints, 1 on the top, 1 on the bottom. It's just like if you had a 5 on the top and the 5 on the bottom. 5 divided by 5 is 1. 1 times anything isn't going to change, so they cancel out. So that's why we canceled them out. Now, the only unit that we have left here that didn't cancel out is liter, and that's exactly what the question asked, was to convert this to liters. So now we take this and we multiply across the top. 12 times 1 is 12, and 1 times 2.1 is 2.1. And then you divide that. 12 divided by 2.1 is about 5.7, and our unit is liters. Example 2, use dimensional analysis to convert 4 inches to yards. So we're starting with 4 inches, and we're just going to put a 1 underneath of it to make it a fraction. We're going to have to multiply it by a conversion factor. We are changing it to yards, so we have to know how many inches are in a yard. Well, there's 36 inches in a yard. Okay, so inches is on the top of my first ratio. So in order for it to cancel, I need to put it at the bottom. And our conversion factor says 36 inches is 1 yard. So then we can cancel out the unit that's on the top and the bottom, and we're left with yards. And that's what the question wanted us to convert to. So we are going to multiply across the top. 4 times 1 is 4, and 1 times 36 is 36. And then we are going to divide 4 divided by 36. And I get an answer of 0.1 repeating. And this question said round to the nearest tenth if necessary. So this would be about 0.1 yards. Now we're going to move into converting rates. So the only thing that's going to change is instead of putting a 1 under your first number that they give you, they're going to actually give you a number to put down there. So a rate is miles per hour, miles per gallon, that sort of thing. So example 3 says a cyclist travels 105 kilometers in 4.2 hours. So we have 105 kilometers over 4.2 hours. So always what they give you is what you start with. Make a fraction out of that or a ratio. Use dimensional analysis to convert the cyclist's speed to miles per minute. This is important. Miles and minutes. So that means I have to change both units. So I'm going to have a couple of different conversion factors in order to change these. Write your answer with the correct number of significant digits and use 1 mile is about 1.6 kilometers. So let's take that. We have to do one at a time. So I'm going to pick the kilometers. We need to change it to miles. So if kilometers is on the top and I want it to go away, I'm going to put it at the bottom. And we're going to change to miles. So I'm going to put miles up here. They told us 1 mile was 1.61 kilometers. And then we can cancel out our kilometers. Now we're left with miles on the top and hours on the bottom. But the question asked for miles per minute. So I have to have another conversion factor. Hours is on the bottom this time, and I want it to go away. So I'm going to put it at the top. And we're going to change this to minutes. I know that 1 hour is 60 minutes. That's the conversion factor that we're going to use. And hours is on the bottom and hours is on the top would cancel. And the units now that I have left are miles and minutes. And that's exactly what they asked for. So we are going to multiply across the top and I would get 105. And then I'm going to multiply across the bottom and I get 405.72. Now I have to do the division of 105 divided by 405.72, and I'm going to get about 0.2588, and our unit is miles per minute. So that's about 1/4 of a mile per minute there that he can travel. Now we have to look at converting areas. So the area of a practice field is 45,100 square feet. So 45,100 feet squared. How large is the field in square meters? Write your answer with the correct number of significant digits. Use 1 meter is about 3.28 feet. We are going to make a fraction out of that since this is not a rate. And then we have to multiply by a conversion factor. So this is feet squared. They told us 1 meter is about 3.28 feet. And if I want feet to cancel, feet has to go on the bottom. So 3.28 on the bottom and 1 meter on the top. But the 45,100 is square feet and the 3.28 is just regular feet. So we have to square this, which means that, move it up, we have 45,100 feet squared over 1 times 1 meter squared over 3.28 feet squared. And now we have to square that 3.28. And when you square 3.28, you get 10.7584. 4 feet squared. And 1 squared is 1, so we don't have to change the top number. So now our feet squareds could cancel out. And at the top, 45,100 times 1 is 45,100. And 1 times the 10.7584 would give us 10.7584. We have to divide that. So when we divide that, we're going to get about 4,192.073, and that would be meters squared. The directions said that we have to round that to the correct number of significant digits. So looking back at our problem, we had 45,100. That has 3 significant digits. And the 10.7584 actually has 6 significant digits. So the rule said that we have to round to a number with the smallest amount. So we have to round that 4,192.073 to a number with 3 significant digits. So what that means is that I'm going to have that 419, and I can put a 0 at the end. So I would either have to, so I have to round that 4,192 rounds down to 4,190. Remember, when there's a 0 at the end, it does not count as a significant digit. So we would only count the 4, 1, and 9. So this has 3 significant digits. So that's the correct rounding. And the label is meters squared.